Moulds and the development of mould growth. There's some moulds. Notice quite heavy mould, different colours. There's black mould there, there's these yellowy sort of ginger mould, there's actually some green mould if one looks at the colours very carefully. But where we go is we have distinct variations in colour depending on the species. And again, it shows up much better on this mouldy ice cream that was left out. We have yellow moulds, blue-green, white, black, pink, different colours of mould species. More mould, black mould, typical triangular pattern in the corners where the air is very stagnant. Cold patches, cold spots. Window reveal, commonplace. Over a cooker. And this is where somebody was breathing on the wall where they slept. And finally, with reference to this is missing insulation around the perimeter of a room, and the temperatures show where the insulation is missing. This is a black mould. It's actually developed beneath wallpaper. You can see the staining on the surface, but the mould itself is under the wallpaper. This is caused by a wet wall, not by condensation. Again, similar pattern caused by dampness within the wall itself, not condensation. Sometimes one may come across this. These are houses 10 years old. You can see the lightweight block, or rather the outline of it, in the mortar beds, and it's known as grinning or pattern staining. The mortar beds are, in this case, about half a degree cooler than the block itself, and when one does a tape lift, there's no mould there, it's purely dust. Indeed, the surface temperatures here were always 4 or 5 degrees plus above the dew point. It is simply dust. Why it collects on the colder spot, I don't know. But here's just the example, looking at a thermal image of this. It shows up the cold spots. So back to moulds then. There are over 100,000 species of mould worldwide, but less than 100 are common in the UK. The most common being Penicillium and Cladosporium species. Stachybotrys shatarum, a so-called toxic mould, is uncommon but not rare in the UK. So the basic features of mould: they have simple food requirements, and like all fungi, they produce vast numbers of spores, and they can grow quickly under suitable conditions. In other words, we can regard them as very much opportunistic. They have the same requirements for growth and survival as rots, or indeed any other fungus. They require oxygen, air, suitable temperature, nutrients, and moisture. Moisture is really the only effectively controllable factor. And the requirements for mould growth on a particular substrate depend on water activity, or hygroscopicity of the substrate, airflow, and of course relative humidity. The life cycle of a mould is very simple. We start off with a spore. These are floating around in the atmosphere, and they can be very, very high in number. Simply float around. If they land on a suitable surface where the conditions are right, they will rapidly germinate, produce these hyphae, thin filaments, and we get a mass of these where they become known as the mycelium. Within the mycelium, the fruiting bodies or sporophores develop. These contain the spores, and these are effectively budded off and get carried away around in air currents. Here's some spores: Chaetomium species and Cladosporium species. Cladosporium is a common black mould, and sometimes I believe it's referred to as the king of the black moulds. That's Cladosporum cladosporoides. Occurrence of moulds in buildings. This was published in International Biodeterioration Bulletin, and some research done at BRE. And you can see the common ones: Aspergillus, Cladosporium species, Penicillium species. Large numbers, percent in all dwellings sampled. And again, those species are present in the air. The other two, the Stachybotrys and Fusarium, are not particularly common in air. And one should always consider that microbial contamination in buildings can vary greatly. And notice its presence in a building alone does not constitute exposure. It is important, however, to note that the long-term maintenance of high humidities, we're talking here in excess of 80%, without condensation, causes moulds or some moulds to develop in stagnant areas, especially on moisture-sensitive materials such as leather, some cloths and paper. And what species of mould grows where depends on a number of factors, but especially the humidity and the particular substrate. And of course the colour of mould will depend on the particular species. And this shows up the different colonization of moulds. They can be split into primary colonizers, requiring RHs of up to about 80%, 75-80%. Secondary colonizers, they will germinate and require 80 to 90% RH, and the tertiary colonizers 90% plus. So we have this different requirements for different levels of colonization. And it's highly likely that much of the mould in buildings does not require condensation. It develops via these primary and secondary colonizers due to very high humidities developing. And here's some examples. We've got wood and wood-based materials, 75 to 80%, so we can get the primary colonizers on these. Similarly on paper and plasterboard, secondary colonizers, mineral insulation materials, secondary and tertiary colonizers, extruded polystyrene, tertiary colonizers more or less, concrete, tertiary colonizers. It depends on the material. And this is a good example of mould on leather due to maintenance of high humidities. This was a wardrobe, it was monitored, there was no condensation anywhere in there. High humidities were high simply because it was so cold. And in this case, the mould developed on the leather, notoriously susceptible to moulds, and it never developed on the clothing. It never developed on the clothing, purely as a result of the very high humidities being developed in it, simply due to it being very cold. Rather an interesting case as well, mould bloom on a party wall. Again, it's resulted from persistent high humidities, and the arrow showed this bloom. Interestingly enough, nothing showed even on the corner of the right-hand wall. It was that particular wallpaper that showed all this bloom. Condensation never occurred on that wall. And again, mould caused by maintenance of high humidity. There's the photograph. Mould only developed on the moisture-sensitive board on the back of the unit. It never developed on the painted wall where condensation actually occurred. And this was simply caused by the high relative humidity which developed in the cold stagnant air behind it. And this is the actual data from there. Note the wall behind in green dropped below the dew point, hence we got condensation periodically. The back of the sideboard never did, or the back of the unit never did. And this is where the mould grew, because that particular material was susceptible to mould, and we're probably looking at primary or secondary colonizers. And again, a similar factor. This was mould on the back of a picture. It had developed on that picture simply because that material was particularly susceptible to mould and very high humidities were present in that room. So then, to summarise, many moulds found in houses do not require surface condensation for their development. Primary and secondary colonising moulds only require relative humidities maintained in excess of 80% to develop on certain moisture-sensitive materials.